What I like to say about packing problems is that they're easy to state, but they're extremely difficult to solve. If you take 3 pennies like this and put them together in contact, they form an equilateral triangle. That is locally the densest way that you can pack 3 pennies. If I take this building block, I can tile the space with these triangles, okay? And then I can create the globally densest packing. And now I'm going to imagine that I have a compression process and I do it rapidly. What I end up getting is not something that's disordered, but it's actually very close to this crystal arrangement. That's one interpretation, that this is in fact the most disordered arrangement that you can have of pennies when you compress them rapidly. One of the things that we showed in this PNAS paper is that these disordered packings of pennies do exist. They have a much lower density than these ordered ones, or ordered-like ones, and that they are in fact disordered as measured by what we call order metrics. The innovation in this paper is to have used this new algorithm that enables us to find large packings that have completely different characteristics. First of all, they have a much lower density. They also have fewer neighbors in contact. Plus, I can't do anything to unjam the system. And those states were thought not to exist. The traditional notion of randomness, which is rooted in statistical mechanics and thermodynamics, is associated with entropy. What that boils down to is, what are the most probable states, the most probable configurations that arise when you undergo a certain process? And if there are many, many, many such states, then we think about that as high entropy and high disorder. Based upon this definition, then, that randomness has to do with what are the most probable configurations, you would say that these are indeed the more disordered states. We would argue quite the opposite. As long as I can find a single configuration and I can measure the order metric and show that it's much lower than this particular configuration, which is highly ordered, then I've done something very, very significant. To have tools that help one to characterize different degrees of disorder all the way up to the most ordered is extremely broad. It applies across many of the scientific fields. What does it really mean for, let's say, cancer cells distributed among healthy cells? They have a certain degree of order or disorder to them. Now that we know that these kinds of states are possible, it redirects research. So you would never think that pennies would be able to tell you all of these interesting things about these fundamental issues, but they in fact can.